So welcome everybody to week 8. So I just want to start off with making a couple brief announcements really quick. And so for the first announcement I want to go over is the course schedule. So as you can see here, you should have submitted your A3 and a research proposal draft by Monday of week 8. And so you don't have anything due next week, but there is a final delivery of all research presentation materials due 2 weeks from now. And let me open up the project just so we can go over that portion of things. And so in this deliverable, you'll be making updates from the proposal draft. You'll be making updates from things I've mentioned to you. Maybe you'll be changing the direction of your paper a bit. You'll be making whatever modifications you see fit for your final project. This is considered your final report for the class. This is kind of like the big end of term project that you're working on. So just like the items in your proposal draft, your final research package proposal should include this. The one thing that it does not need to include for now is this poster. We'll talk about the poster a bit next week as far as how we're going to do that with an online course. So it does not need to include the poster. We'll touch on that next week. But it should include the final deliverable of your proposal draft. So you'll be getting feedback from me on the proposal draft very soon if you have not gotten it already. So I think that's it for announcements. So what I want to talk about today are correlation metrics. And I want to start off with looking at some really weird correlations. And this is a site I found that has some pretty ridiculous correlations. As you can see here, here's the amount of U.S. spending on science, space, and technology, and the correlation between suicides by hanging, strangulation, and suffocation. Now, looking at this graph, it looks like there's a pretty darn close correlation between U.S. spending on science and number of suicides by these mechanisms. Now, there's probably no logical correlation for this. It's probably all by sheer luck. But like you'll see with this, there's really high correlations between these two items, and I think they're probably all by sheer luck, but I think some of these are interesting to look at. This is one of my favorite. Number of people who drown by falling in a pool correlates with films Nicolas Cage appears in. And so even just by looking at the graph without doing any kind of formal correlation analysis, there's a pretty significant correlation, pretty high correlation with the number of films Nicolas Cage appears in by number of people who drown by falling in a pool. Now, maybe from this I could derive that people intentionally drown themselves in pools because they saw a horrible Nicolas Cage film. I don't know. But there's a lot of really interesting correlations here. I won't go through them all. I think this is funny. Total revenue generated by arcades correlates with computer science doctorates awarded in the U.S. So maybe when people get their computer science doctorates, maybe they go spend a lot of time at arcades. I don't know. But this is a pretty, I think, funny site, pretty interesting sites. Pretty interesting site for showing different types of correlations. And so that's what we're going to talk about today. We're going to touch on correlations. While like last week when we spoke about statistical analysis, this is not a stats-based course, but I do want to just really explore and expose you folks to some different types of correlations out there, and so you know how to do them for your projects, and so when you're reading about them in papers, you have a decent idea of what's going on with their correlations. So the question we're going to search about today is how to determine a correlation between items. And the correlation between items could be the temperature and how much water you drink. If there's a correlation between, I don't know, the amount of food you eat during a sporting event and if your team wins. You could pretty much draw a correlation between any items. And so some terms we're going to throw out to start is a linear relationship. And you would sometimes measure correlations in terms of a linear relationship or non-linear relationship. And basically, a linear relationship is a relationship that's directly proportional. So one linear relationship that probably would occur in real life is the number of cheeseburgers I eat a day by the number of weight I gain. So if I'm eating 10 cheeseburgers a day, I probably gain much more weight than if I eat 5 cheeseburgers a day. A good old-fashioned example could be this example I have of the minivan, where it's driving at a straight speed along a highway, and it takes a certain amount of time to get there. Therefore, it would be a linear relationship between those two items. So you can think of a linear relationship as like a direct relationship between two items. And we'll talk about that in a little bit. Another term I want to throw out there is how to interpret results. And what we are going to talk about today are strong and weak correlations. There's virtually a correlation between every item. Now, it may be very weak, but there's probably going to be a correlation between every item. There's may be a strong correlation between different items. And you'll see correlations measured in plus and negative ones. So an item could have a negative relationship of 1 up to a positive relationship of 1. So it's a range of -1 to 1, and 0 would show there's basically no correlation between the different items. So we'll talk about these numbers in a little bit. So different types of correlations. You can have a positive correlation, a negative correlation, and really little or no correlation. So in this chart on the left, it represents a positive correlation because even just from the grouping without running a statistical analysis, you can see as the bottom arrow, it goes to the right and it goes up. Therefore, you can see the number, you see the dots are grouped together. You can see as one item grows, so does the other. And so you see the positive correlation because the values are going up over time or over values, I guess you could say. And a negative correlation, it's really just the reverse, where values go down over time, or as the this axis was growing, as this expands, values generally go down over time. So you can have positive correlations and negative correlations, but between both of these charts here, just by making a visual analysis, just by looking at the charts, you can see that there's a grouping between the different items. And the far right-hand side here, that's generally what we'd say is no correlation, or very weak correlation is probably a better term. And that's where there doesn't seem to be a rhyme or reason between anything. It just seems to be a scatter plot of dots. So these are different types of correlations. So like I said, you can have a positive correlation, a negative correlation, or a weak or no correlation. So some correlation examples are shown here. Some are positive correlations, some are stronger positive correlations than others, and here's some here's some negative correlations, and they get weaker over time. And so from the positive correlations example at the top, you can see a pretty tight grouping of the different items, and they go up over time. So you could say a positive correlation. And it's got a pretty tight grouping, and in this case has a value of 0.7. Now, don't worry about where that value of 0.7 came from. We're going to see how to calculate that in a couple slides using the Pearson correlation. But since it has a higher value closer to 1, you'd see a tighter grouping here. There's still a positive correlation here, but it's a weaker grouping, so it's a weaker correlation. Therefore, this value is 0.3. So there's not as high as a correlation as there was for this 0.7. Now, if this was a 1.0 correlation, it would essentially be a straight line. You probably couldn't even see any dots. It would just be a straight line of dots. There'd be no separation between them. It would just go linearly up over time. Now, a correlation of 0, this shows that there's just no rhyme or reason. There's really no correlation. There's a very weak correlation between the items. And so it would have a very low correlation value. Now for here, you'll notice these values actually are in the negatives because they are negative correlation. So it has a negative correlation of 0.7, and you can see it does have a tighter grouping, just like the tighter grouping for the 0.7 value. But in this case, it goes down, so it's a negative correlation. Here's another example of a weaker negative correlation of 0.3. And there still is a correlation, reasonably strong correlation between the items, but it is negatives, and you can, even from looking at it, you can see that the grouping is much weaker. And again, if there was a -1 correlation, you'd see a straight line. It would be a perfect straight line. And then the correlation value of 0, you can see that there's really no rhyme or reason. They're just grouping between the items. So this next slide is generally a rule of thumb. So that don't take this as gospel. Don't take this as being like it is the way it is. This is just a rule of thumb as a way to say if something has a small, medium, or large correlating value. So generally speaking, a value of 0.1 to 0.3 or -1 to -0.1 to -0.3, you could say that's a small or very weak correlation. A medium correlation would be 0.3 to 0.5 or -3 to -0.5, and a large would be 0.5 to 1 or -0.5 to 1. And so the way you would measure the strength of association goes up as the value gets closer to 1 or -1, and you can really see that from the previous slide here. Okay, and so there are a couple different types of correlation metrics you can use. These are just some of them. You can use Pearson correlation metric, and that's where it checks to see if things are linear related. Kendall looks at ranks of data, and Spearman also looks at ranks of data. So we won't get too much into Spearman or Kendall today, but just know as if you're doing your readings, you may see Spearman or Kendall mentioned as far as correlation metrics, and you can definitely read more about those items. But today we're just going to focus on Spearman correlation. So the Spearman correlation measures the strength of association between different items. So one way to think about it is Spearman would give you this R value that's being defined here. So that's where this value could come from, is by using Spearman. So some Spearman examples could be as if there's a statistically significant relationship between age as measured in years and height by inches. Is there a relationship between the temperature measured in Fahrenheit and ice cream sales measured by income? Meaning the amount of money that came in from selling ice cream cones. I'm guessing there would probably be somewhat of a correlation here, because if it got to be a 100-degree day, people are probably going to buy more ice cream, versus a day when it's -10 out, people probably aren't going to go to too many ice cream stands. And is there a relationship between job satisfaction as measured by JSS and income measured in dollars? So do people that make more money, are they generally happier based on surveys? So these could be some correlations you could look for as far as a Pearson analysis. Obviously, there's pretty much an infinite number of correlations you could look at. These are just 3 of them. And so I did create a hands-on example that we'll go over briefly now of a Pearson analysis. Now, if you really want to get into robust statistical analyses, there's a tool called R, and that is very powerful, and that's a fairly complicated tool to use. I'm sure if you roll up your sleeves for a couple hours and you run some basic R scripts, you will start to get a reasonably good grasp of R. But R is a tool for another course. It's something you might use on your with your advisor. They may have you use R. But if you're really into doing statistical analysis, R is a great tool. But for the purposes of this course, we're just going to use a simple Excel document. So I have an Excel document already open, and you can download the Excel document using this link. Okay. And in this document I have here, let me just expand this. Let me see if I can blow this up a bit. I'll zoom in. I'll zoom in 150. And so in this Excel document, which like I said you all have access to, I have one set of values of age, and I have another set of values of weight. And then I have the Pearson value being calculated here. Now I'm using Excel for this because Excel already has a Pearson calculator built in. If you're really interested in reading about Pearson, Kendall, or Spearman, there's formulas that you can use. I'm not going to get into those formulas in this course because essentially they get too deep into statistics for this level course. Plus, frankly, I've never really had to need to use them. I just end up using calculators, either in R or in Excel, to perform the correlation association measurements. But for here, what I did is I assumed we took we did a study where we took the person's age and then we took the person's weight. Now, what we have here is we have 2 people with the age of 23 and a weight of 100, 120. We have a couple young people here. Apparently there's a 3-year-old with a weight of 2. That doesn't seem very healthy. We have a 3-year-old with a weight of 6, a 1-year-old with a weight of 5. I guess these are very small humans. And then we have a 50 and 60-year-old with a weight of 200. So just from this example, we can see that there's a very, very strong correlation between age and weight. Now, if we want to play around with this a bit more, let's say we're going to make the 3-year-old have a weight of 500 pounds. Now let's watch what happens to the Pearson value. It goes way down, because what we're then doing is we're weakening the association between the values of age and weight. Because the other values, there is a pretty good correlation, but this value of 5 totally throws off the results. So it moves the Pearson score down to 0.09, which is essentially no correlation, or you would, to be more accurate, you'd say it's a very, very, very weak correlation. If I want to do the same thing and make this other 1-year-old 500 pounds, you can see the correlation value goes even lower. It actually goes in the negative range. So it's actually saying there's a negative correlation between the values of age and weight. So I would encourage you to play around with this Excel sheet a bit more. Try some different correlations. See if you can do a simple correlation study on your own. I'm going to open up a My Courses Dropbox. Okay, so what I'm gonna do now is, sorry for that little hiccup, is I opened up a week 8 discussion section, and in this discussion, what you should do is find a simple correlation study, and this could be something really simple to do, like I don't know, the number of hours you sleep in a day versus the temperature, or the number of books you read in a year based upon your age. Really just find some simple analysis you can do. Frankly, come up with whatever you want as far as analysis. Heck, if you really want to make up the numbers, you can do that. But try to do something reasonably realistic. Maybe it's the number of people committing to a GitHub project and the number of bugs found in the project. And you only need to do maybe a 5 or 10 app analysis if you do that. Really just come up with whatever correlation metric you can think of and collect the data, but spend no more than 10 or 15 minutes on it. And try to have a little bit of fun if you can. Then discuss how did you conduct your analysis. What was your correlation value, meaning R value? So if you did Pearson, what was this calculated value here? And then really just briefly discuss what this tells you. Discuss if there's any implications for this simple study that you did. And I think that's really it for today. I do have a couple different notes on Pearson correlation, and there are a couple different sections on the course resources page. But that's really it. Please let me know of any questions, and we'll talk next week. Thanks.